Welcome back to the new video, that is set structure. Basically, I'll be talking about set. What is set? There is another data structure that is called set. So let's delete the previous thing. I'll be talking about set. So what is set? I'll be talking about set. So what is set? So set is a data structure that maintains a collection of elements. Okay. So set having the basic operation like insertion, searching, and removal. Okay. So set is basically based on balanced binary tree, and its operation work in omega log n time. Okay. So let's see about the set. So what is set? What is set? Set is a data structure and data structure. And what is data structure? Data structure is the way to store the data in the computer memory, right? And basically that maintains a collection of elements. Right, it's maintain the collection of element. Okay, and then it is having some basic operations. That means you can say functionality of the set, that is insertion, and then searching and removal. Removal, that means deleting something, right? Like we have seen in previous video in vector, that pop back function, like that. Okay, so basically it is based on a balanced binary tree, right? So what is balanced binary tree? So you don't know about the tree, but I can show you here what is a tree. Let's say, suppose this is an tree. Sorry, we'll have to take the ink. It is erasing. I have to writing, right? Okay, so let's see. So this is, so this is a tree. So this is a tree. This is the node, root node. You can say in Hindi आप कह सकते हो कि ये जड़ है. Then this is a child of a tree, that is left child. This is right child, and this is another node, and this is the left child of this node, and this is the right node of this right child of this node. This is the left child of this node, and this is the right child of this node. So this is node. What? Node. It is difficult to writing here. This is node, and these are child. This is left child, ch for child, left child, l dot ch. And this is right child of the node. Right, like that. So what is valence tree? It is balanced. Why it is balanced? Because you can see it has a left child, it has a right child, and also this child have their left child and right child, and these are balanced. You can see this is the level of tree. This is one level, this is another level, right? So these tree are called balanced tree. Balanced in the sense, that means which tree that will having like as well as left child, also right child. That node and that tree will be called balanced tree. So it is based on the balanced binary tree, right? And it will it's all operations like insertion, searching, and removal work in omega log n time. Okay, so let's see and implement the set in the compiler. So first of all, we need to let's mention it is based on balanced binary tree. All right, make it as a comment, double slash for the comment, right, in the compiler. That will be not executed, remember it. So let's implement the set. So hatch include, first we'll have to take the library function bits std c ++ .h using name space std and end main. Basically programs begins from here, whatever the written in the curly braces that will be executed. So let's make a set. So set, and we will be taking a number. So type of the set is integer. Yes, set s, and the variable name is s. Okay, and we can insert it, we can remove the element, and we can also search an element in the set. So let's insert the element. So s dot insert one, like that. So let's copy it. As a computer science, we'll have to manage the terms, so that's why I'm copying. Control V, Control V, Control V, Control V, and let's put the different element in that. 2, 3, 4, and then 5. All right. Okay, so now the point is coming to print out this element, right? So how to print out this element? So printing this element, we will basically use a loop, that is shorter way loop for auto x containing s elements, and we will be print out the element in x, right? And then new line. Let's save it, Control S, and then run. As you can see, the elements are printed 1, 2, 3, 4, 5. Okay, this is insertion, that we have inserted the element in the set. We can also initialize element. We can give initialized set in that. So how we can initialize? So s is equals to curly braces, like element is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then delete these things. Let's make a note as a inserting element these functions for inserting element, and this is initialized set. All right, so let's remove this, delete, and then Control S, and then run. As you can see, elements are printed 1, 2, 3, 4, 5, 6, 7, 8, 9. So how we have initialized the element and inserted the element 1, 2, 3, 4, 5, 6, 7, 8, 9, And for the printing, we have used for loop, that is the shorter way of the for loop, that is auto containing s elements into the x, and then we are printing element into the x, right? This is for printing element. All right. Also, you can count the number of the element in the set. So suppose I'm taking here 3 dual time. Dual time, that means दो बार ले रहे हैं 3 को, एक बार दो बार. So let's count how many times we have 3. Okay, so how to take it? So cout set s dot count will be counting 3. How many times 3 is taken in the set, right? Double slash n and then termination. Let's see. 1. It is showing wrong, sorry. I think we'll have to put in into under the loop. Control V and make it as a comment. It will be not printed. That is not working. What happened? Oh, that will be printed. That will be work when we will be inserting the element, right? So suppose let's try with different thing. Suppose we have taken the set type of integer, yes, and then inserting the element into the set, yes dot insert. One, and let's copy this. Control C and then Control V and then Control V and then Control V, right? One. Suppose we are taking 1 as 2 times, so this is 3 and this is 4. So let's see, is it counting or not? So to counting how many times an element is present in set, we will use s dot count. So cout set s dot count will be counting 3 1. How many times 1 is present in set? Let's run. What happened? Control S. One time. This showing here. I think it is taking from. Let's make it 1. Control S. Oh, sorry. This count function is basically giving the confirmation about that element present in the set or not. If it will be present, that will be printed 1. If it is not present, then it will be printed 0. Right? This is the working of the count function. Right? Suppose we are not having the 5. So suppose we are searching 5. So that will be give us 0. It will be work as a boolean, false or true. So that will be, if the 5 is present, that will be printed 1. If the 5 is not present in the set, then it will printed 0. Let's see. As you can see, 0 is printed because 5 is not present in the set, right? So make it also clear, easier to understand you. Let's begin another session. So s is equals to suppose I'm taking elements 1 2 3 4 5 6 7 8, right? This is initialize set, this is initialize set, and then let's search an element. Basically count is for searching. I'm sorry, I was talking wrong. So count is for searching an element. So suppose count searching 2. So what we'll have to do, cout set s dot count, suppose 2, right? So 2 is present in set or not, let's see, double slash control s and then run. So 2 is present, definitely it is going to show you 1, I think. Okay, exactly 1 is showing because what we have searched, we have found. We have searched 2 and 2 is present in this set. Suppose 9 is not in the set. So let's see, we are searching 9. Cout yes dot count 9. So 9 is not present in the set, so I think it will be print 0. Why? Because 9 is not present. As you can see, it is printing 0 because 9 is not present in the set. Alright, so this is all about set, I have told you. And basically the important property of set is their element are distinct in nature, right? So the function count always return either 0 or 1. If the element present in the set, that will return 1. If the element is present not in the set, that will be return 0. So we are having three properties in set, that is insertion, searching and removal, right? So if you wanted to remove something, like remove an element, you can basically type s dot erase, that will be erase. Suppose I'll be erasing 6 from here, right? Let's see, let's print that. After that we will erase 4. This is low auto and x containing the elements of set s, and then curly braces, and then cout x, because x is containing elements of set s, backslash n, and then control s. As you can see, elements are printed 1 2 3 4 5 6 7 8. Okay, and let's erase an element. Erase, that means removing of element. So suppose set s dot erase, let's erase 7. Okay, 7. Let's see it's working or not. 6 7 8, it is not working. Why? As it should be in under this. Yes dot erase 7. As you can see, 7 have been removed. Okay, so what we have learned about the set is having three operations, that is insertion, removing and searching. For the searching of an element we will use count, and for the removing of an element we will use erase, and insertion of the on an element we will use insert, right? So let's make it clear here. This is initialize set, this is printing, or iterating the elements, and this is removing, and this is searching. Searching, that means when we will search an element in the set, if the element present in the set, we will see 1. If the element present not present in the set, we will see 0. That is the scenario working of an set, right? So okay, thank you guys, this is all about set, and let's see next video. I'll meet you. Thank you.